Okay, so in this video, we're looking at writing down the nth term for a sequence. So previously, we were given an nth term and we were looking at finding the first 5 terms or a specific term in a sequence. Now we're given the sequence like here, and I'm going to write down the nth term for that sequence. Before we look at this though, there's something that I want to go through on this slide, on this slide here, because I think it's really important that we really understand this. So what I've got here is I've got just 3 really simple sequences. The first one is just 1, 2, 3, 4, 5, which is basically just your 1 times table, okay? Because we can see we are increasing from term to term by 1. We're going up by +1 each time, +1, +1, so on and so forth. So my hands are really cold, so my writing might be a little bit dodgy. Yeah, we're increasing by +1 each time. And the question is, right, because we're looking at the nth term here, how would you write this sequence in terms of n? And the answer is just n. Okay, so the nth term of this really simple sequence increasing by 1 each time is just n. Okay, you're going up by 1 each time. So the one down below, we've got 2, 4, 6, 8, 10. That is increasing by +2 each time, or you could say it is your 2 times table. It is your 2 times table. Okay, you're going up by +2, +2, +2, so on and so forth. It is your 2 times table. And the question is, how do you write your 2 times table in terms of n? It is going to be written as 2n. So your 2 times table, which has a +2 increase from term to term, you write as 2n. And the reason is, right, because 2 is your first term, you would do, well, 2 times n, your first term is 1. Your second term is 4, so n is going to be 2 there. 2 times 2 is 4. 6 is your third term. 2 times 3 is 6. So 2n produces your 2 times table. So similarly below here, we've got the 3 times table because we're increasing by +3 from term to term, +3, +3, +3 again. Well, this +3 increase we show as 3n. So 3n produces your 3 times table, which has a +3 increase. And these really simple ideas and sequences are just useful to know for when we get into harder questions. Okay, so you might be thinking, well, if you had a +7 increase, you would just write it as a 7n, and that is absolutely correct. How about though for the ones on the right? Very similar, but you can see they're negative. So not 1, 2, 3, 4, 5, but now -1, -2, -3, -4, -5. It's kind of like your negative 1 times table. So now it's not going to be written as n, it's going to be written as -n. If you're decreasing this time, it's going to be minus, and because it's just going down by 1, -n. So similarly here, this is your effectively your 2 times table, but your negative 2 times table. So it won't be 2n, it's now going to be -2n. And again, the reason is your first term there, where n is 1, so -2 times by 1 is -2. Your second term, n is 2, so you replace n with 2, -2 times 2 is -4. But just know, right, that if you're going down by 2 each time, so here we can see we're decreasing by 2, we're going down by 2, down by 2, down by 2, we write that as -2n. So similarly below, right, -3 decrease, we write as -3n. And again, if you had a -10 decrease from term to term, you would write it as -10n. So if you need to, make a note of this stuff because it's quite important for when we get back onto this kind of question here. So what we'll do is we'll go through 3 examples and you can try 3 yourself at the end on writing the nth term. So the question says, write down the nth term for this sequence below. The first thing you've got to do here is you've got to see, well, what is the increase or decrease in this sequence? And we can see, right, we're going up by +3 from term to term. So we're increasing by +3, by +3, 11 to 14, +3. So we're looking for that constant linear increase, which we have in this term here. And because we are increasing by +3 from term to term, well, to show a +3 increase, we've just seen from the previous slide, a +3 increase from term to term, we can write as 3n. So we're going to write this +3 increase as 3n. And this is the way I like to lay out the working for this kind of question. So we know the 3n produces the 3 times table. We've just seen that. So that's going to produce the sequence 3, 6, 9, 12, 15, 18, so on and so forth, which is different to the sequence that I want. 3n produces the 3 times table. I want 5, 8, 11, 14, so on and so forth. But there's something we can do here. To get from 3 to 5, what do you need to do? Well, if you added on 2, you would get there. From 6 to 8, if you add on 2, you get there. 9 to 11, if you add on 2, you get there. So if we go and add on 2 from these red terms to the ones above, we get the sequence that we want. So we've got to go +2 to each of these numbers here to get to the ones that we want above. Therefore, the nth term of the sequence is going to be, we've got the 3n there, so 3n, and we're adding on that 2, so 3n plus 2, and that is our nth term for this sequence, okay? And really important, we can always check our working. Okay, let's go and check the fifth term here. So this 17 is your 1, 2, 3, 4, fifth term. Or you could say, so that's right, check our working. Right, 17 is our fifth term. In other words, when n is equal to 5 and I put it into my nth term, I should get 17. Let's double check it. So here we're going to get, well, 3. My n value is 5, and then I'm adding on 2. This means 3 times 5, which is 15. If I add on 2, indeed, I get 17, which is my fifth term. So this is definitely correct. This expression, this nth term, describes this arithmetic sequence. Arithmetic just means I'm adding or subtracting by the same number each time. Okay, that is it. The first one done. We'll go through a couple more examples and then you can try 3 yourself on the next page. But this sequence here, right down the nth term for the sequence below, well, this time you can see we're actually decreasing, and we're decreasing by a constant number, which is 4. We're going down by 4 from term to term, 2 to minus 2, down by 4, down by 4. Okay, so in terms of n, because we're writing down the nth term here, well, if you had a plus 4 increase, that would be written as 4n. But because we're going down by 4, we write it as negative 4n, as we saw on that kind of one of the earlier slides. Or 4n would produce a 4 times table, but we've got minus 4n, so it's going to be the negative 4 times table. So minus 4, minus 8, minus 12, minus 16, and then minus 20, and it would keep going on, so on and so forth. Right, so minus 4n produces this sequence. I want the one above, which I've got to do something to get from here to above. Well, to get from minus 4 to 10, I've got to add on 14. Minus 8 to 6, I add on 14, so good. I've got that constant increase. Minus 12 to 2, I've got a plus 14. So to the right of it, to get from the sequence minus 4n to the one above, I've got to go in plus 14 to each of those numbers. Therefore, my overall nth term sequence is going to be minus 4n, which is this part here, plus that 14. And that is the nth term of that sequence. Or you could write it, because usually in maths we like to write the positive parts first, we could write it as 14, take away 4n. They both mean exactly the same thing, okay? So either of those is absolutely correct. Okay, so that is my answer, or the one below. Absolutely fine. And again, let's just go and check our answer. Okay, let's go and check. Let's go and check our second term this time. So that's when your n is going to be equal to 2. That's your second term. So when n is equal to 2, and we put it into our nth term, we should get 6. Let's check it. We've got minus 4. My n value is 2. So minus 4 times 2 plus 14. Minus 4 times 2 is minus 8, plus 14 is indeed equal to 6. So correct, that is good. So this is definitely correct. Checking your work is always a really good thing to do. Okay, example 3, right down the nth term for the sequence below. It looks a little bit trickier because we've got decimals and it's negative, but it's the same idea going on. So first of all, are we increasing or decreasing? We're actually increasing because we're getting kind of, we're getting bigger, aren't we? So we're going up by what? We're going up by 0.5. So from term to term, we are increasing. Oh, it's not very neat, sorry. We're going up by plus 0.5, plus 0.5, plus 0.5. Okay? And similar to over here, right, how do I show a plus 0.5 increase in terms of n? Because I'm writing down the nth term. You would write it as 0.5n. Okay? And a bit like minus 4n produced the minus 4 times table. This is positive, but 0.5n will produce the 0.5 times table. So we're going to get 0.5 and then add on another 0.5, which is 1. Add on 0.5, 1.5, 2, and then 2.5, so on and so forth. So 0.5n produces this sequence. I want the one above, which how much bigger is it? It is plus 3 bigger. To get from 0.5 to minus 2.5, I've got to add on 3. 1 to sorry, I've got to take away 3. 0.5 to minus 2.5, I take away 3. 1 to minus 2, I take away 3. 1.5 to minus 1.5, I take away 3. So just be a little bit careful there. We've got to go and subtract 3. Take away 3 from each of these numbers to get to the ones we want above. So my nth term here is going to be that 0.5n. And I've got that take away 3. Take away 3. So that is my answer. And again, let's highlight it, because that is our answer. And let's check our working. That's always a really good thing to do. Okay, particularly when they get a little bit tricky like this one here. Let's check our fourth term. That's your 1, 2, 3, fourth term. So that's when n is going to be equal to 4. Your fourth term, put it into your nth term. So we get 0.5 times by n, which is 4. Take away 3. 0.5 times by 4, or half of 4, is 2. Take away 3 is equal to minus 1, which indeed is what we've got there. So definitely I'm correct with my nth term. So checking your work, really, really important, particularly when you first start doing this. Okay, good. So what you can do now is you can pause the video, you can try 3 questions yourself, and then I will go through them. And you can fast forward to the end to mark your work, and that's going to be it for this video. So all these questions here is just saying write down the nth term for the sequences below. The first one, right, what are you increasing or decreasing by? We're increasing by +2, +2, and +2. We've got a constant increase there, which means it is an nth term one. So +2 increase in terms of n is going to be written as 2n. 2n produces your 2 times stable, 2, 4, 6, 8, so on and so forth. But that's not what I want. The sequence I want above is 1, 3, 5, 7. Well, to get from 2 to 1, I take away 1, 4 to 3, take away 1. So I've got to go and subtract 1 from each of these numbers here. I'm going to go and take away 1 to get to the sequence I want above. Therefore, my nth term is going to be 2n, take away 1, and that is my answer. I'm not going to go and check it because I just want to get through this quickly for you guys, and that's going to be it. The second one, we are decreasing this time, and we're decreasing by 5, so we're going to be going down by 5, down by 5, and then down by 5. Well, to show a -5 decrease in terms of n, it's going to be -5 and then n. So that's going to be your 5 times table, but negative, so -5, -10. It's quite important you get your numbers to line up, otherwise it might look a bit confusing. And then -20, so on and so forth. Actually, it is very important to make sure your numbers line up, otherwise it will be confusing. But to get from -5 to 9, what you need to do, you need to add on 14, -10 to 4, you've got a +14, so good. We've got a constant increase there of +14. Therefore, my nth term is going to be written as -5n plus 14. That is my answer, or you could write it with the positive part first as 14, take away 5n. Either of those is definitely good to go. So either of those is absolutely valid and most definitely correct. Good. Last but not least, we've got decimals and we're decreasing, but it's the same idea again. So here we are decreasing by -2.5, we're decreasing by -2.5, we're decreasing by -2.5. So we've got a constant decrease there, which means in terms of n, we can write it as -2.5, -2.5n. So your first term is going to be your 2.5 times table, but it's negative, so your first one's going to be -2.5, and then -5, -7.5, and then -10, so on and so forth. But that's not the sequence we want. We want the one above, which is +7.5 bigger, isn't it? So to get from -2.5 to 5, we've got to add on 7.5, add on 7.5, add on 7.5. So let's go and show that over here, being consistent with how we're showing our work. So we've got to go and add on +7.5 to each number. Therefore, my nth term is going to be -2.5n plus 7.5, or I could write it again with the number positive part first, 7.5, take away 2.5n. Either of those is definitely correct and most definitely correct. Okay, so that's really good. Good, so if you got that, that is fantastic. That's something else that you can do. Grade for writing down the nth term of sequences. Thank you.